Alrighty, good morning guys. Last week we were talking about how we are going to be moving away from finding the equations of lines and being able to graph lines, and we're going to presume that you guys all know that now. So hopefully over the weekend, if you felt like you didn't understand any of that, you put some practice in, or maybe you went along to support maths or something like that. But yeah, now we are jumping in to be looking at simultaneous equations. Now if you think about the word simultaneous, what it means is at the same time. So we're talking about simultaneous equations. We're talking about equations that happen at the same time. Now on this graph you see we have two equations. One with the equation negative x plus 7, hence why the line is a negative gradient, and 2x plus 1. You also will note on the graph I've marked the point of intersection. Now we can see it's where these two lines cross over. You can see it cross over when x is 2, when y is 5. So that is the intersection of these two graphs. Now it's quite clear to spot this point of the x intersection at 2 and 5, and it's quite easy to read off the graph. And what this point means is at this point here, both the value for x for both of these lines and y are exactly the same. So when x equals 2 for both of these equations, y equals 5. So what we say is at this point the two equations are simultaneous, which means they're occurring at the same time. However, sometimes it's not always so easy. So if we're looking at this equation here, we have half x plus 4, so you can see it crosses at 4 and it's going up a gradient of half. And then we have this kind of fractional gradient here, 4 over 3x. So for every 3 it goes across, it goes up 4 squares. Now, with this one here, you can see here the point of intersection. Now, if you look at the point of intersection, you see that it doesn't cross perfectly on the grid line. It crosses just a little bit to the right of it, which means it's going to be not as easy to find that point of intersection because it's going to be some kind of decimal value. And we don't really want to be estimating that. We want to find some kind of way that we can actually calculate what this point of intersection is. So estimation isn't good enough for the scheme of this because sometimes we need to know the exact value. So we're going to develop a method or use a method that we can solve these two problems. And that's called simultaneous equations. And that's what we use to solve this problem. Okay, so if you think back to the first graph, we had two equations, 2x plus 1 and negative x plus 7. Now, when these two equations are the same, both of the y values are the same, which we found was 5, and both of the x values are the same, which is 2. But since this here equals 5 and this here equals 5, that also means that this here has to equal 5 and this here equals 5. Alright? So what it's saying is this side here is equal to this side here. So since those two are equal, we can actually just write them as equal to find when they are the same. So that's what we do. We end up with writing 2x plus 1 equals negative x plus 7. So now we have an equation that doesn't have any y in it. Now, since we only have one variable, we can just go about and solve that equation. So we're going to go about and solve x. We're going to be using some of our algebra skills for that. And to start off with, we want to have all the x's on one side and all the values on their own on the other side. So for instance here we can have all the x's on the side, and let's try to get all the numbers on this side of the equal sign. So let's start off by cancelling out this negative x here. So to cancel that negative x out, we're going to add an x to the side, but if we're going to add an x to the side, we also have to add an x to the side. So we're going to add x to both sides, and that's going to give us 2x plus x is 3x, we'll still have the plus 1, and negative x plus x is going to cancel out, and that will just leave the 7 there. Okay, so the next step is to get to move this negative 1 or cancel out this negative 1 from the side. To do that, we're going to take away from 1 from the side, and in terms of equality, we also need to treat the other side the same as well. So we're going to subtract 1 from both sides, making this side 3x, and 7 minus 1 is 6 on this side. Finally, it's 3 times x equals 6, so we're going to do the opposite of timesing by 3, and that's dividing by 3, so that makes that x equals 2. So now we have found the value for x equals 2. So that's what we found on the graph. We saw that they crossed over when x was 2. Now we just need to find the value for y. Now once we've found the value for x, we can then use that value for x, which in this case is x minus 2, and substitute it into any of the original equations. It doesn't matter what equation you substitute it into, because we know that both the y values should come out the same. Okay, so in the scheme of things, just choose the easiest one that is to calculate. Yeah, so I'm going to choose the first one because it hasn't got a negative x here to deal with. So I'm going to use the equation 2x plus 1. Now I'm going to replace x with the value I found for x, which is 2. So it's going to become, instead of 2 times x plus 1, it's going to become 2 times 2 plus 1, which we know equals 5. So therefore, when x equals 2 and y equals 5, we know that's when the two equations are the same, or when they intersect. And that's what we read from our graph earlier. Now, I want you to have a go over this example here. If you want to watch back over that example I just went through, that's fine. But I want you to have a go of this example. So pause the video and have a look and have a go for yourself. If you get stuck, that's okay. I'm going to go through it after this. If you want another example to look at that's written down, if you grab your Gamma textbooks, there is an example on the top left-hand corner of page 125, which is also, you'll be working off that page later on in the lesson. So have a go for yourself, and we'll go through it shortly. So here is the example. Y equals 3x minus 1 and 2x plus 3. So you can find these two equations are the same because we know we want to find both when both y's and x's are the same. So we know that this side here is going to be equal to this side here. That's what we write there. And just like the last one, we want to then go find the x value. So we solve for x. So let's have all the x's on the side and all the numbers on the side. So let's start off by moving the x's. So we've got 2x's on this side, so let's take away 2x from the side, and then we can take away 2x from that side as well. Cool. And that will give us x on the side, because 3x take away 2x equals x, and take away 1 on the side. And on this side we've got rid of the 2x, so it's just 3 on the side. Next, we want to get rid of the take away 1, so it's just x on the side, so we can add 1 to the side and add 1 to the side, and that gives us x equals 4. Now we've found x equals 4, we need to find our y, and we do that by putting it back into one of the original equations. So I'm just going to use the first one. Okay, so we'll put 4 into the original equation here, so 3 times 4. Take away 1, so that's 12, take away 1, and so y is 11. So then therefore, when x is 4 and y equals 11, the two equations are the same. Cool, so now you're going to have a go for yourself with exercise out of the Gamma box. We're going to be working on the page 125 that I mentioned earlier, and exercise 10.05. In order to solve the equations this way, we need to make sure that both of the equations are either y equals or x equals x equals. So if it's x equals and y equals, we're not going to have to solve it using this method. So we're going to need to rearrange the equations to make sure that they are in that form. So make sure the equations are rearranged. If you get really stuck, ask a classmate. For someone that was here yesterday, most of the class seemed to really grasp it well, and they should hopefully be progressing on to the next part today. So yeah, just ask them and hopefully they can help you out. If not, any questions, I will see you last period tomorrow.